exciting. Buenos dias. Welcome, Vidal Salazar, to our humble little Zoom session. And right now we have some educators. We already have participants here. We'll probably be getting more in. I sure hope so. I did a lot more promoting today. I really, really feel like your message is powerful. I've heard that um, you have a really amazing background. And so we're excited to be motivated, inspired, challenged by your presentation. And this is great because we're going to recording this and then we'll be able to put it in our resource bank and we'll be able to see you anytime. So our teachers can go in and the Future Center Bank and they can go ahead and show this to their students later. And I think it's really wonderful. I know you have a really amazing journey starting as a Mexican immigrant child to work your way towards your dream job here at NASA. So this is going to be exciting to listen to, and I'm really excited and anxious to hear it. So I'm going to hand it over to you, and if you need anything, you can just shout out. I'm here. I'm sitting here listening. Okay. Thank you.
Thank you. No, thank you, and thanks for the invitation. I really like doing this, type of presentations because sometimes I think it's important for the kids to know somebody or to have some kind of role model, that they can relate to. I came from Mexico. I did all my education in Mexico, and like everybody else, I had very big dreams, and I'm happy to say that my dreams have become true. I mean, when I was a little kid, I wanted to work for NASA. I remember seeing all those rockets going into space, and as a maybe as a 10-year-old, thinking like, well, will I ever be able to work at NASA? Will I be ever, be in one of those rockets that go to space? I had those dreams when I was a little kid, and I'm not in one of those rockets, but I do work for NASA. So I have a little presentation that I want to share with everybody. So let me share my screen. And so I'm going to start. I hope you can see my screen right now. So thanks everybody for joining me, and thanks for the invitation. Like I said, this is really important for me. I like sharing my story with all the kids to understand that they can too make their dreams come true. This is important. It's important because unfortunately, the next generation of scientists is diminishing. We really need a lot more people interested in science. We really need those students that are coming up to go to college, to choose science careers, because science is what moved this world. Science is what puts us in this earth, and I think it's important for everybody to be excited. I'm so excited about my job that I hope my excitement gets transmitted to all of you. So, like I said, I work for NASA. I've been working for NASA for 5 years now. Let's see, where's my screen? There we go. And I like to start with this little picture over here. I mean, NASA is known for all the space exploration that we do. And like I was mentioning before, when I was a little kid, I wish, I wanted to be an astronaut. I wanted to be in one of those rockets that were launched into the space, into the moon, into the different orbits that we have. I like to put this picture. Unfortunately, this is not me. I wish it was me, but my career took a different turn. I'm a project specialist with NASA, and my office is at the NASA Ames Research Center in San Francisco. And my excitement in science became known by me when I started studying Earth type of research, Earth science projects. So all the work that I do for NASA is very, very much based on Earth observations. So anything that has to do with how the Earth functions, the flow of air, the flow of moisture around the Earth, how hurricanes form, how cloud forms. So that's what I became really interested in me. So even though I am not, this astronaut on the picture, but I work for NASA, and that was, my dream that that became true. My title right now is Astrophysics and Planetaries and Atmospheric Science, and I work for the Earth Science Project Office. And like I said, the Earth Science Project Office does mostly research that is related to the Earth type of project. This is my group at NASA Ames. So the group that I work, you know, is a very diverse group. We have Latinos, we have Americans, we have Indian Americans. We have people that are very specialized in what they do. And everybody, like I said, everybody's so excited to work at NASA, and everybody's so excited about the Earth observations that we try to collect. We have all kinds of workers. Like I say, I'm an astrophysicist, but NASA requires the expertise of many different types of people. We have biologists, we have chemists, we have computer programmers, we have sociologists. So, you know, one of the questions that I always get is like, well, I really don't like science, but I like, you know, I want to be a psychiatrist. Can I work for NASA? And my question is like, yes, you can work for NASA. You know, like I said, NASA requires every single expertise, every single person that is excited about contributing to society. As a psychologist, for example, you could work at NASA studying how astronauts react to being confined to a small space. Or, you know, because sometimes astronauts in the future are going to have to go to places like Mars or the other planets. You know, they're going to be confined into small spaces, so that affects the psyche of people. So I mean, there's always opportunities at NASA to do your own research. It doesn't matter what kind of field you're in. So like I said, I work for the Earth Science Project Office, and the work that we do at the Science Project Office is related to how we observe the Earth. And as everybody knows, you know, we have satellites orbiting the Earth right now. All of those satellites that NASA owns and operates are to observe the different types of meteorological phenomenon that we're observing on the Earth. So, as you know, this picture you're seeing on your screen right now, we have many satellites, and this is just the research satellites. Research satellites, I mean, these are type of satellites that are doing observation to do, not just to do like weather forecasting or to communicate. You know, we have as you know, when you're making a phone call, and you know, when I'm talking to you on Zoom, by the internet, all the communications are via satellite. So we have a lot of a communication type of satellites, but the satellites that I'm showing you in this picture are satellites that are doing Earth observations. They're monitoring weather patterns. They're monitoring temperature changes, and so those are the satellites that my group uses to conduct the type of research that we go around. So these type of observations, you know, are related to the hydrological cycle. I'm sure that everybody, all the students attending this session, they have heard about the hydrological cycle. The hydrological cycle is nothing but just how the water gets distributed around the world, and how the different phenomenon like the radiation of the sun, the human activities producing CO2, how the photosynthesis happen, how the rain falls. You have glaciers that are contributing. So all this phenomenon that occurs on the Earth affect how the patterns you know, that we're observing on the Earth. So my work is to study these types of patterns, and to do that we use the satellites, and we have airplanes that are equipped with the latest technology on atmospheric science, and I'll show you a few pictures of them. So I work also for the Airborne Science Program for NASA. So we have a fleet of different airplanes that we we equip with the latest in technology to do atmospheric measurements. So what we do is that we take these airplanes around the world, and we fly just below the satellite, to make sure that whatever the satellite is measuring, we do in situ observations with these airplanes just below the satellite to, to improve the measurements that these satellites are collecting. This type of work has taken me basically around the world. The observations that we do are very, very diverse. We do collaborations not only with airborne type of research, but we do, water, ocean observations. We collaborate with institutions that have research vessels that they sail around the world, and we fly on top of them, using our lasers to do the atmospheric type of measurements. So it's a combination of airplanes, instrumentation that goes into the airplanes, the satellites, and then we get to observe and produce, scientific papers that talk about how the weather is changing, how climate is changing, how the rain patterns are changing. I mean, and these are all really exciting topics for, everybody's interested on how much snow we're going to be getting over here, or how much rain we're going to get in the summer, because then you start getting into problems that, if we don't have enough rain. See what happened this last summer. We get a lot of fires, forest fires. The forest fires produce a lot of particles that go into the air, and all these particles that go into the air interact with the clouds. They affect the rain patterns, and it's just a vicious cycle that gets just repeated over and over again. So it's important for us to to understand this earth science type of programs. These are all the past missions that I have participated on. So each batch that is right here is a different mission. I have been deployed pretty much in every single continent in the world. I have the opportunity to work with different students from different universities, from different high schools around the world. And sometimes everybody speaks a different language, but the commonality here is that everybody's excited about science. Everybody's excited about doing Earth observations, and we collaborate, we do research, and then we publish papers to help the scientific community understand what's happening in the world. I mean, it's important to get to know the place that we live in, and we only have one planet that we live right now, which is Earth, right? So we are trying to understand it to improve our life in this planet, and that's the main goal. I wanted to give you just a quick example of one of the projects that I did. So the ATOM project is the atmospheric tomography mission. But this project was really exciting because we flew. This was the first project that we took an airplane, one single airplane, just on a trip around the world. And you can imagine. So when we work in the U.S., when we work in a single country, you're focusing on one university, on one language, for example. But when we ran this project, the ATOM project, we were in 12 different countries, speaking different languages and 12 different universities. So you can imagine the craziness that it was to manage these type of campaigns. But it was very exciting because, we did a trip around the world measuring CO2 type of measurements. So as the carbon emissions are being looked at because the human activity is producing so much carbon that is affecting our atmosphere. So the scientific team of the ATOM project was interested in understanding and better understanding the global view of carbon distribution. So in this graphic over here, the pink line shows us how we flew to the different countries around the world. And as you were flying into different countries, the plane was going, as high as 55,000 feet, and then going as close to the water as they could, doing a zigzag pattern, up and down, up and down. And they did that because they wanted to measure the different layers in the atmosphere, the different concentrations of CO2, and get a global view of this CO2. And just to give you an idea, before CO2 was measured in a single place in Hawaii, so one data point for the whole, the whole Earth, one single point. So with this project, you get to get a different view. You get the layers of the atmosphere. You get a better representation of CO2 that can, help you understand how the distribution is being made around the world. So the scientific impact of this campaign was amazing. And the results were, the people are still looking at the different type results that we get. So these are some, some of the plots that we got from those campaigns. The distribution based on latitude. Again, you go with a plane up and down, and like I said, I got the opportunity to fly in this, and these are not regular flights. These are flights where you're observing, you're looking at your computer, you're seeing all the measurements that are coming in, and your plane is going up and down. So this is not like your commercial typical flight. It's very exciting. It's a very exciting thing to do. I always enjoy talking to all the people inside the plane. See, and these are just the same flight patterns that we were flying around. And this is just a quick view of so the instrumentation. So every single box over here on the plane is a different type of instrument. These are instruments that are also mounted on the satellites. These are instruments that are mounted also on the aircraft. And so, like I said, we were flying just below the satellite. This is the satellite. We were flying just below the satellite to corroborate all those measurements and make sure that whatever we were measuring was accurate. And like I said before, these are not typical flights. This is the inside of the aircraft. So each instrument has a little rack within the instrument, and you as a scientist, you will sit on front of your instrument and you're monitoring all the data that is coming in. So like you said, there's no flight attendant, there's no meal service. The only meal that you get is the meal that goes to your brain, all the knowledge that you're gaining in this project. But it's exciting to participate in these campaigns. These are just some more examples of places. I think this project, this is one of the stops that we did in Namibia, in Africa. It was a really cool experience participating in this campaign, flying with all these people around the world. And when I was a kid, I would have never thought that I would be doing this when I was a little kid in Mexico. This is the team that we took around in the DC-8. So just some quick examples. And like I said, I never thought that I would be doing this when I was a little kid in Mexico. My family is from Torreon, Mexico, northern Mexico. And I did all my my undergrad research, undergrad classes or undergrad degrees in Mexico. And then I had the opportunity to come to Denver to work for NCAR. I'm sure you guys ever, if you go to Boulder, just before you come to Boulder, there's the building up on the hill, the National Center for Atmospheric Research. They basically saw me in Mexico. I was doing some research in Mexico, and they saw how excited I was about doing research. They invited me to come to Boulder to pursue my atmospheric science degree. So I immigrated when I was 20. What was it? 21, 20. Just before I was 21 years old, I moved to Boulder to do my master's and PhD in astrophysics and planetary science. And these are just some typical examples of, just like everybody else. My family is still in Mexico. These are my mom and dad and my sisters. And I have my family now here in the United States, in Denver. Bob, my partner, and my little doggy Felix. We have one more doggy that we adopted. Um, but after working for NCAR for 20 plus years, I had the opportunity to apply for a position at NASA. Um, Unfortunately, the position in NASA, it was in San Francisco. So I'm one of those super commuters that lives in a different city that you're working with. But because of the type of work that I do, I travel all over the world. I go to different places, and so I don't really have to be in my office very often. When I do have to be in my office, I go to San Francisco at the Ames Research Center in San Francisco. But yeah, like I said, I grew up in Torreon, in Mexico, and now I split my time between Denver and San Francisco. That's, in my eyes, is a very successful career. And so, and I just wanted to show you also some pictures that, like everybody else, these are some pictures when I was in high school. I was the king of my elementary school. I have friends, that right now they're also very successful in their own careers. But this is, I wanted to put these pictures in there because these pictures represents when I was starting to have all these dreams of, doing research or becoming something big. I always wanted, I always had my eye in the horizon. Um, I knew that I wanted to do research. I knew that I liked science. For me, science was exciting. Doing observations of different phenomena was amazing for me. And like I had a very normal childhood, just like all of you. Um, and I'm happy to say that my childhood dreams became true. I'm a researcher right now. I do research. I do Earth science observations, and I work for NASA, um, and it's very, very excited. So just a little bit of background. Also, in the 90s, I have a technical degree in computer programming, with a bachelor's degree in chemistry science, in organic science, and I did all of those degrees in Mexico. And I got my master's degree and my PhD in astrophysics and planetary science. And I worked for NCAR for about 20 plus years. And I get a lot of questions, what should I study? What should I specialize myself on? And there's not really, secret recipe. I think whatever you get excited about, whatever topic you're interested on, that's the topic that you need to concentrate on. Um, I was a chemist. Now I'm an astrophysicist. So, life takes you in many, many directions. And I think the best tool is just to be prepared and be excited about what you do. I did a lot of computer programming classes. I'm really good in Excel, Google products, etc. And at this time in my career, I do a lot of project management. I do a lot of planning, implementation, and scientific field campaigns. I have a very long curriculum of scientific field campaigns in different countries. So I think this is I have more 57, 58 scientific campaigns in more than 40 different countries. And so this is part of what complemented my education and what helped me get the job at NASA. When I apply for NASA, NASA is very competitive. For every single job opening, there's hundreds of applicants. So you have to show NASA that you're not only just capable of doing the work, but you are also excited about doing the work. Sometimes it's more important to show people that you have the willingness or that you are excited about doing something. When you have a degree, you already did the classes, you have the knowledge, but having the will, having the excitement of doing something, that's probably that will set you apart from everybody else. Oh. I wanted to finish my presentation with this multi-view of the Earth. This is satellite observations from 2017, which is one of the busiest years that we have for hurricanes. But this is one of my favorite videos, plots, because it shows three different contributions to the atmosphere. It shows smoke. Smoke is represented here in white. It shows sea salt, which is like spray from the oceans, and represented in blue, and it goes to white. And then we get dust that is mainly produced by the Sahara Desert. So 2017 was one of the most busy hurricane seasons ever that we ever had, and we seem to hit the record every year after that. I mean, 2020 we had hurricanes. We run out of names for the hurricanes. So the atmosphere is becoming more and more unstable, and it's important for us to understand what's happening. I like this plot because it shows three different contributions, but these contributions are not isolated from each other. These contributions mixed together, they affect one another. So the Sahara Desert, for example, in this plot, is interacting with the sea salt and the smoke from the other phenomenon to create these amazing superstorms. And before a few years ago, scientists were just interested in understanding one topic. People were concentrating only on the Sahara Desert dust or the smoke. Nowadays, all these problems that we're seeing are because all the interactions that we see in the atmosphere are interconnected. So the observations that we need to do these days is a mix of parameters. It's a mix of disciplines, a mix of scientists that we need to understand. So I just wanted to give you a quick global view of where we are. So with that, I'm really excited. Thank you again for having me over. I hope I gave you a quick overview of what we do and what I like to do. Again, I'm really excited about doing this. I go to work every day with a smile on my face, and contributing to how we understand the Earth and how we are coming up with different solutions to problems that we have is what keeps me going. Participating in science is amazing, and if a little bit of my enthusiasm gets transmitted to you guys, we do need new scientists. We need the next generation that is going to help us to solve the problems in the future. So I want you guys to be the next generation, and I want to do everything I can to get you as excited as I am. So with that, I'll be happy to take any questions.
Okay, thank you so much, Vidal. I wrote a few of your little nuggets. I mean, what an inspiring story. Really great information. I do have a list of questions here for you. You might have gotten that one sent to you personally. Can you hear me, Vidal? Oh, it says I'm muted.
Are we muted?
Yeah.
Yvette, we can hear you.
Can you guys hear me? Okay. All right, great. It says that I was muted. Okay, good. I'm glad I'm not. All right. Vidal, I have a few questions here for you.
So I'll keep an eye on the
chat
question.
Okay, you may have some private ones on your end that I didn't see, but I have a few on mine that I to ask you. The first one is, does NASA collaborate with NOAA or Sandia National Labs? If so, can you share any examples? Could you hear me? You done? Hello?
Yvette, we can hear you, but for some reason he's not able to hear you.
He's not, is he?
Did I lose you?
Hear me? Vidal, can you hear me? Let me send him a message.
There we go. Sorry, I'm sorry. I
Can
got
you
you.
hear me now?
Yeah, I can
Oh,
hear you.
okay.
Yes.
I was like, okay, sorry. All right. Let me repeat the question. The first question we have here on the chat is, um, does NASA collaborate with NOAA or Sandia National Labs? If so, can you share any examples?
Yes, a lot of these campaigns that I was showing you that happen around the world are multidisciplinary. You know, I showed you the last slide. You know, NOAA, for example, NOAA, NIST, DOE, the Department of Energy, um, the EPA, NASA collaborates with different agencies to create these observational campaigns. So one of the best examples, actually, one of my campaigns that is coming up, we're going to be deployed out of Cape Verde in the Atlantic. And we have a lot of the space agencies from Europe coming with their airplanes and with their radars and with their observational platforms, you know, to study hurricane formation as well. So we're all going to be meeting in Cape Verde, and everybody's bringing their own toys to do the observations. So, like I said, you know, these field campaigns are multidisciplinary, multi-agency, and you know they're super big. There's about 400 people coming all together to study hurricanes from all over the world. So, you know, we never do anything by ourselves. It's always collaborating with different people.
Awesome, thank you. I hope that answered your question. If not, I did put his information on the chat, and you can ask him more personally, more specifically. I'm going to get to the next question. The next one is, what would you tell someone that would like to go in a path like yours? This is from a student. What would you tell them to do, or what kind of guidance would you offer them?
I will say to them, take every opportunity that you can. You know, sometimes, you know, I always, you know, blame my parents. My parents were very encouraging of me. You know, my parents, you know, I was always very inquisitive. I always wanted to take classes of this, classes of that. You know, I went as far as I wanted to take, you know, guitar classes because when I was a kid, I wanted to be a mariachi. You know, being from Mexico, I wanted to be a mariachi. I love Mexico. So, you know, when I told my parents I want to be a mariachi, my dad is like, sure, here, go and take a class. You know, the best thing you can do for something that you want to do is take a class. You know, understand what you want to be, understand, you know, what takes for you to be something that you want to be. So my suggestion from anybody is that specialize yourself, take classes, whatever thing that interests you, just go and take classes. It doesn't matter what it is. You know, everything adds up, you know, to your expertise or to your personal repertoire of things that you're known for, and everything is helpful. Everything will help you in your career. If you're interested in painting, take painting classes. You know, painting, art opens up your mind, makes you happy about what you're doing. You know, never stop exploring, and always take advantage of the opportunities that are there. There's a lot of scholarships to, you know, for Latinos, for Latino kids. There's a lot of scholarships for underrepresented minorities. Take a look at those scholarships and make sure that you know, you apply to them. You know, a lot of people that I talk to is like, oh, I don't know if I'm gonna qualify. I don't want to apply because I don't know if I'm gonna qualify. Apply. I mean, apply. Never think that you're not gonna be good enough for something. You're always good enough for everything that you put your mind into. And that's been my motto ever, you know, forever. Can you imagine if I thought that I was not going to be NASA, you know, material? And I mean, it can, you know, it did cross my mind. Well, I don't know if I'm going to be good enough to work at NASA. but I decided, no, never mind. I'm just going to apply. I have the, the capability. I have the credentials. Um, I am material for NASA. So I applied and I made it. So apply, take advantage of the opportunities. Never said that you're not good for something.
Awesome. That is fantastic advice.
Mhm.
Next question is, would you say NASA is an achievable goal for people who can put their effort into it? I think you just actually answered that question. So
Yes,
that,
for sure.
yeah, perfectly. Now we're going to go, we have only until 9. So there are several questions. I want to get through a few of these so we don't miss any. Next question is, what would you tell someone that would like to go in your path to take? Did I already ask you that one? Maybe that came twice.
Yeah, yeah.
Next question is, what tools and instruments do you utilize for your job?
For my job. So, because the type of research that we do is top of the line, newest type of research. So we have a lot of in development instrumentation. We have instruments that are just new, that are just coming up, that they're being developed for the type of observations that we're doing. Depends on the type of measurement that we're doing, but we deal with LiDAR type of measurements, radar. When it comes to observable remote sensing type of observations, when we do like in situ, when you take collect samples, for example, when we go through a cloud, you can take a sample of a cloud, take it inside of the airplane, and analyze the water that that the cloud is composed of. By doing that, you can analyze the chemical components inside of the cloud. You see if the cloud is being affected by some human activities. So the instrumentation that we take is the airplane goes through the cloud, the instrument opens up a valve, the cloud water goes inside, and then we take that water inside a spectrometer type of instrument. So it's very it's very wide, the type of observations. Yeah.
Awesome. I bet. So the next question is, was it hard to do? These are from students. Was it hard to do? Was it a lot of work? Also, what kinds of things can I do to help me to be able to achieve things like this? So I guess, was it hard for you? Was it a lot of work? And then in summary, what do you recommend as far as like classes they can take, things where places they can volunteer, different areas that they can explore? What would your advice be for that?
My advice will be, like I said at the beginning, places like NASA, places like NCAR, they require of every single expertise, in the world, from a plumber to, a legal assistant, to a lawyer, to a psychologist, to a scientist, to a mathematician. So, science is not just mathematics, chemistry, physics. Science needs all the other expertises. So for me, it wasn't. I guess my suggestion would be that just keep doing what you're passionate about. Keep doing what you're passionate about. Keep exploring what you are excited about. When I was in grad school, when I was in undergrad school, I was passionate about chemistry. I was passionate about organic chemistry, and for me, this might sound a little bit weird, but I was so excited to go and take all these organic chemistry classes, going to the labs and mixing things, seeing the different colors that change and knowing why they change colors was super exciting for me. And it wasn't something that was forced to do. Not even myself, because going to class was exciting. Going to class, going to the labs was so exciting. And this is the way that I kept doing things in my career. When I just kept exploring things that were exciting for me, and this is where I got. So do the things that you're excited. It doesn't matter what it is. Again, science and NASA and every single place in the world, every research institution requires everything, every expertise under the sun. And to work in a place like NASA is just, again, is not what what expertise you bring to the table, but it's how excited you are, how good you are at it. And when you are excited, you're really good at it because you're doing the things that you enjoy. So just do the things that you enjoy, and life will take you in the right path.
Absolutely. I concur. I always tell students, do what you love and you won't feel like you work a day in your life.
Exactly. No.
There's one other question. It says, does any of the data collected from these missions ever get told to the general public? If so, how? Also, is it also shared with the U.S. government to help shape policy? There's three
Yes.
different
Yes.
questions. Do you want me to repeat the first one? Does any of the data collected from these missions ever get told to the general public?
Yes. So all the data that we publish, normally, the scientists, they have 1 year to do their own analysis. After 1 year, the data becomes public domain. So, universities, research centers, schools, they have the capability of just going to a website and say, like, I want data from this campaign, and it becomes, data publicly available. That's one way of sharing it with the public. The other way is that scientists publish, they do, for example, they do an analysis of climate change, for example. They do a scientific, what we call a scientific paper, and is published into a scientific journal. When the scientists publish into a scientific journal, they explain what they're doing. They go through the whole scientific methodology. They plan their hypotheses, they do the objectives, they explain how the questions that they're trying to answer. They use the data to answer these questions. Everything is on the paper. So all those data and all those explanations are in the scientific papers. So there are groups of scientists that use these different papers from a specific topic, and they use these different papers. They use all these different observations to study the phenomenon that we're trying to understand, like in this case, climate change, for example. And then this group of people, they are in charge of creating policy. They go and to Congress, and they tell Congress, the scientists are observing this. The scientists are observing that there's a change in the global temperature. So we suggest that we do this to correct the problem. Or the scientists are also giving me this solution to the problem. So that's how the government at the end gets involved in this situation. So we have different levels of communication.
Awesome. Thank you.
If that makes sense.
Well, it's as much as it can. I'm sure. For someone who doesn't study science, but I'm sure it's quite fascinating. There is one request before we end our session today, and it's saying, can you talk a little bit about being an immigrant and coming to the U.S. and the challenges you had to overcome? And I mean, at the end of the day, if I know today was about your career and about question and answers, what you do, but maybe in another session, I'd love to have you come back and talk about this a little bit more thoroughly. I'm trying to have like these special guest speakers who talk about their lives and the hardships that we went through growing up. And we can talk about our careers all day, but what is it about? What does it look like to get through that and onto those types of successful things? So go ahead and talk about that if you can.
It was coming to the US was, I grew up in, like I said, I went to college and everything in Mexico. So I thought that, I saw the U.S. in like as something, something exciting, something that I wanted to explore. I didn't really know. I thought that my career was going to be set in Mexico. I thought that I was going to, do my whole life in Mexico. I do want to maybe make sure that people, for Mexico has its problems and everything, but there's a lot of opportunities for people that have a college degree and that they're specialized. There are opportunities in Mexico. When I was when I was finishing my undergrad, I got this opportunity to work at a U.S. institution with, and when you're in research type of situation, working at a U.S. institution, that means that you have a lot of resources that you probably don't have in Mexico. So that's why, that was one of the reasons that I decided to take on this opportunity to explore, an international type of community. Coming to the U.S. was not very easy. It was very, very hard. English is my second language. When I was 20, I didn't really started actively speaking English until I was 22 years old. Coming to the US and with an even heavier accent that I have right now was very difficult. Going to the classes, people really didn't understand what I was saying. And they were not interested in understand what I was saying. So that was one of my biggest, things that I had to overcome. Being heard, it was difficult, but like I said, I was always excited. I was this little, excited kid that it didn't really matter that they didn't understand what I was saying, but I was hungry to transmit what I wanted to say. So I said it one way, I said it another way, and I make sure that they understood what I was trying to say. People they do look at you in a different view when you are an immigrant. We do have the stereotypes. I had to fight a lot of stereotypes also to get where I am. We have the stereotypes of Mexicans being lazy, and I always wanted to fight against that stereotypes. I always and again, sometimes when somebody doesn't understand what you're saying, you tend to to be shy, and it's like, okay, I'm just going to go away. But that was never me. That was I wanted to be heard. I wanted to be heard, and that's something that my parents taught me. My parents always taught me how to to speak up. Never, when you have something to say, just say it, and if they don't understand you, try to say it in a different way. But yes, I would love to talk more about this. I mean, it wasn't easy. It was not easy at all, especially not speaking the same language. Going to classes, going to grad school here in the US was very, very difficult. And I'll give you just a quick example. I'm sure we're running out of time, but in Mexico, when you go to classes, when you go to the university, you're treated more like a unit of students. So like if you don't understand something, when I was in the chemistry class, my chemistry school, if I didn't understand something, my friends from school will help me understand it. When I came to the United States for grad school, everything is more individualistic. That help from my peers wasn't there. And, I found myself being alone, basically alone, trying to, to go through these like high level classes. I'm sorry, my dog is barking now. But that help from my peers wasn't there, and that was like the biggest cultural shock for me. So you can imagine, I was barely able to communicate what I wanted to say, and taking all these classes, and nobody really wanted to help me. So it was a cultural change. It was a very cultural shock to me. Um, but again, my parents always, I do remember talking to my parents. I was like, I don't want to do this anymore. I'm tired. Nobody listens to me, but they always encourage me. They always, you can do it. Just keep doing what you're doing. You can do it. And that's why I always think the parents play a significant role on the kids' education. So it's nice to talk to the kids, but I would love to talk to the parents, because they are the driven force for their kids. My parents were, and I'm super grateful to them. So.
That's awesome. We actually have one of our guests today is Claudia Glasscock, and she's the coordinator of our Parent Academy Success Program. And so she's trying to build more of a community around our parents, especially Latino parents, and because they need more support. And if they can hear more stories such as yours, I think that would be really inspiring. So we're going to utilize you as much as we can, Vidal.
A pleasure.
I already have a request that you can speak into one of the Mr. Ferguson asked about maybe speaking to his aerospace classes. So expect an email from him. We really, really appreciate your story. Thank you so much for coming and spending some time with us. It's not the last time we're going to see you. So we shall see you again. Thank you for the introduction and coming with us and joining us. Like I said, this is going to be saved, and if you want a copy of the recording, I'm happy to send the link to you as well. Thank you everyone else for joining us. We really appreciate it. I have to jump into my resume workshop class, but then we also do have another workshop for mental health support with it's called Imagine Project at 10. So we sure hope you guys all either come back or definitely encourage your students to come. But thank you again, Vidal, for coming, and we shall see you again. Thanks for information.
Thanks for the invitation. Thank you.
Bye.
It was
Thank
really
you,
exciting.
everybody.
Thank you. Have a wonderful morning.
Take care. Please fill out the survey. Bye.
Bye-bye.